really a prisoner of my biases. I don't see why anyone doesn't notice that wheels are the most fascinating part of a bike, the key to its speed, and the most beautiful single component. I've spent my entire adult career in the bicycle industry. I think it's been one long obsession with bicycle wheels.
When you get somebody that's just madly passionate about wheels, have done it all their lives, and you get somebody that's just totally passionate about carbon fiber and wheel design and carbon fiber products, you put those two guys together and you're going to end up reinventing the wheel. Max Martin was the aero engineer with Boeing background, and Ric Hjertberg is the man that's been passionate about wheels all his life.
When I first started talking to Max, we dumbed our conversation down. We didn't discuss hubs or rims or spokes. Instead, we talked purely about function. What is the mission of the product? What has it got to do? It's got to rotate around a center, it's got to be a certain diameter, and certain things have to happen. Torque has to go through the rear wheel, brakes have to grab the rim in the front, it's got to hold tires in a certain way, and then he had to know all the loads. What is the side load? What is the stiffness? What's acceptable for resilience and spring rate and so forth? And that's the way an engineer like him works to design something he's never seen before.
It's really important that all the pieces that come in from our supplier out in Seattle are checked for quality, weight. It's also very important that we sand all the bond locations to remove any contaminant that may have gotten on the parts between the time they were made and the time they go into all our bonding jigs.
In wheels, at least, it seemed clear to me that we were stuck in a phase that in aerospace they call black metal, which is when carbon is used to replace metal, but the basic engineering has not been redone. It's just a substitution. Tension is the key to a bicycle wheel, and carbon is like the preeminent material of our time for carrying tension loads. So the two of them are kind of made for each other. The question is, when are they going to meet and fall in love and really make it happen?
So one of the main differences with our process versus other processes out there is we are bonding flat shapes to make a 3D structure. This tool locates the spokes to within a couple thou. It's very important that the spokes are aligned correctly so that once everything's bonded together and we pull it apart and create the tension in the wheel, that we do have a true and round wheel.
There's nobody that takes flat shapes like we do and turns it into a three-dimensional product.
The wheel would have to be deconstructed and then reassembled, every step being a decision made by carbon fiber. Carbon fiber has to be in the driver's seat. From Max's point of view, he wanted the greatest possible control over the laminate, and the only way to get that control is making very thin parts where you have complete access to both sides. Hollow eggshell-like structures, the elegant stuff that we see in cycling, forks and frames and bars, and doesn't allow you enough access to both sides, doesn't allow you the pressures Max is accustomed to get the really high-end performance. When you make laminates the way we're doing it, you get a much more orderly structure. So this laminate under very high pressure has extreme mechanical properties, so we need very little of it. But of course it's 2D. You can't ride a 2D structure. It has to have a 3D bracing shape in order to carry a load. So the next stage after these parts are made and trimmed and cleaned up is to bond them into a 3D structure.
So this is a tension wheel where the two flanges have been pulled apart to introduce tension into the spokes. We use custom tooling machined to within 0.5 to 1/1000 of an inch to define the distance between the two flanges. That and all the other custom tooling we have in-house guarantees that we have the correct spoke tensions, correct dishing, and the wheel comes out both true and round.
As we began to design the wheel, what Max would ask me were options I never had. It's like I'd gone to a new restaurant and there were things on the menu I never thought I could order before. We were able to separate side stiffness from vertical stiffness. In a wire wheel, those two are really tightly linked. You can't have a lot of one without a lot of the other. We could have our wheel extremely stiff for torque in the rear wheel without being extremely stiff for vertical compliance. So the ride quality is quite unique.
it's easy for us to, believe it or not, take more weight out of these wheels and come up with a lighter wheel. We started spending considerable more time on the aerodynamics of the wheels, so we've been visiting wind tunnels and starting to go down that path.
This way of making a wheel is new. It's new to the world. Obviously, it's new to us too. Now, we know more about it because we've been hands-on for 3 years, but it's still new to us. So what's possible is we can't wait to see the next iterations. We've learned all kinds of things. We've just barely scratched the surface.